Uh, got my PhD in 2015. Um, and then I joined IBM Research as a research scientist. Worked on a bunch of exciting stuff, but most of those stuff were not really being at IBM Research, right? It's definitely exciting, but you don't really see the impact necessarily, right? So that's something that at least I personally started missing, right? Because you do things and then the way it is, I mean, Nishant, you might be knowing as well, the way you do things at research, it just moves on to the different team after that. So you really don't see what's happening after that. At least that's what I used to feel. But working with a good team and then joining Merlyn Mind, right? When we started off in 2018, um, made a big difference because we are doing something where we can actually make a difference. We've been there looking at end users, understanding their problems, and trying to uh, help teachers who are fundamental to everything, right? They are the ones who are actually creating and um, shaping the future minds. So it's like trying to help them in any possible way is one of the first things that we started on. So I'm glad to be here explaining about our stuff. And thanks for having us, Nishant. I can get started just
Yeah.
to,
So,
yeah.
so again, thank you so much for I mean the perspective that a researcher brings. To a when you're building a researcher has built a real life system deployed.
Yeah, so something
Unique.
about that, right? As we were discussing before to Nishant, it's something that I was personally found. I mean, maybe this is a good time to just bring forth that message. I'll also ensure that I mention this at the end, right? Because that's been my biggest takeaway over the past 4 years, right? Uh, Actually, more than that, right? Because as a research student, you're a researcher. Your goal is to actually write papers, right? That's the reality. We all focus on writing, publishing papers, and actually, having citations. But that's theoretical results. All you care about is theoretical results. Over time, I've realized this three tracks, right? Research versus development versus product. What does it entail, right? The research is all about making theoretical results, which is definitely needed so that you know your limits. Each of them has its own needs, right? You don't want to solve a problem which theoretically has been found to be impossible. You don't want to waste your time. So theoretical underpinning of everything you do is utmost important, right? On the other hand, development is about getting these off-the-shelf solutions uh, that are general solutions that you can pick and start using, right? That's all about the way I look at development. And when you move it into a product, that's been my experience over the past 4 years, right? R&D is well and good, but then when you think about doing it into a product, you have a new set of challenges. Off-the-shelf solutions don't work. General solutions don't work. You actually have to take an additional step of making a practically usable solution, and that's what my experience with Merlyn has all been about, right? We have outstanding team. The colleagues are like mind blowing. Some of them are here, right? They're really good. They make sure that we challenge ourselves. We are all excited with the same passion of trying to resolve a big problem that users have. So that made us identify that things change when you start thinking about a product. When you start thinking about a practically usable things, it's a total different thing altogether. So that's been my biggest takeaway. If nothing else, I would love if the message coming out of the end of this talk is that research, development, and product are three different tracks. All of them are needed. Each of them has its own challenges, and we all should be ensuring that all of them are given equal importance.
Yeah.
Um,
Thank Yeah, and there's some people joining, and I guess they'll join. And some of you might be familiar with OffNote Labs, might have attended one of some of previous talks, and plus the AirMeet interface. I hope it is. You can see the chat box. So as the talk flows, we keep things very interactive. So it is chat box where you can type in your questions, and I'll be happy to relay them to Aditya. And I think there is also a used to be a raised hands. Okay. Yeah. So okay, I think that's the mode in which we. Well, there is a raised hand interface, but it's a
Yeah,
little bit.
and to repeat, right? This is going to be a complete conversational thing, and we want to keep it as Nishan mentioned it. Any questions and anything, right? If as I want to actually ensure that's a conversational thing. It's not going to be a bunch of
Yeah.
slides or lecture,
So,
right?
so
It's
we
going to
know
be
that
more
it's
conversation.
a virtual interface. Some people hold back their questions. Please don't do that. Just throw your questions in there, and I'll relay them, and we'll have Great session. Yeah. So with that, I'll yeah, Aditya, please could you start?
Perfect.
Yeah.
Just give me 1 second. I'm trying to share my screen. Can you guys see my screen?
Yes. Now it is visible. In the chat box, I've put in a video for the audience about OffNote Labs. Please feel free to view it when you get time. Yeah. Yeah. With that, please.
Perfect. So yeah, we'll just talk about Merlyn, which is our voice assistant, and then just this is the first digital assistant for teachers. So we'll just go through some of our understandings and share my understanding, our understandings of how what went through when we built this. The amazing team that we've had. A very important note is I'm just the voice behind this discussion about the voice pipeline. Um, the work that the team has done is phenomenal and is just trying to discuss it out. Another quick note about what Merlyn Mind has all about, right? It's come up. The idea behind Merlyn Mind is all about trying to build an AI. It's an AI solutions company, right? We're trying to make tools that make your life efficient. Your work has to be efficient. And this can be feasible by a bunch of AI enabled automations, micro automations, simple tasks that can be enabled and made better with AI, right? Um, and another dimension of our whole thing is all about the multimodal interfaces, right? Uh, the world has evolved, right? It's not just a single modality anymore. People don't, the way we experience or behave is not single modality. Then why should our interactions with tech have to be single modality, right? That's the whole idea behind our Merlyn Mind, right? And one of the first products that we've come up is focusing on a very important um, subset of people, right? Which is teachers. We want to make sure that the classroom ecosystem is as efficient as possible by supporting these teachers, right? They do hundreds of thousands of different things. We want to support their workflows, make it efficient. And one of the biggest things that we want to do is make sure that the teacher is not stuck to the desk in front of the classroom, is a part of the classroom, is untethered from the desk, right? That's one of our biggest goals, right? That's been the goal. So the question might arise, why teachers, right? Something that we've been observing over the past few years, right, and maybe a decade or so, right, is that there's been a explosion of the number of applications or the tools and the technology that the teachers have to, and the students too, right, have to manage in a classroom. There is a cognitive overload for everyone, but especially for teachers, right? They must teach in a classroom while managing hundreds and thousands of these things. The applications, new ideas come up, right? Especially with during the pandemic, Zoom has become a big thing, right? Um, and there are different tools. I mean, most of the teachers, right, want to use these tools to ensure that they have an outstanding experience for the teaching experience has to be good, right? And for example, in the US, K-12 students, right, almost 90% of them actually have their own device as well. So add to that additional devices in a classroom, and this just makes it that classroom being more smart, but that also makes it very difficult for the teacher to juggle all these bunch of things. So what we want, the idea was to build this digital assistant Merlyn, right, which kind of supports teachers in doing what they want to do. It integrates with your classroom infrastructure, with your devices, with your appliances, and just make sure that your workflows are as simple as possible. The teacher can actually focus on the teaching aspect and not worry about a bunch of other things that she shouldn't be worrying about ideally, right? It also helps support the students. That is the idea behind it. It ensures that there's more interaction with the teacher rather than with the technology and worrying about things. Allows the teacher to offload a bunch of these tasks to a digital assistant, right? We do have a few examples over here, right? The teachers in the US classrooms, at least, right, have to go, pull plugs, manage plugs, change their displays, and they have these, again, the applications that they use, right, like Kahoot, they use Nearpod and a bunch of these things. So enabling a multimodal um, user experience, right, for these workflows that the teacher has to do is one of the goal of Merlyn, right? Just building this automation, micro automations. Um, so I have a small demo over here of we don't have the teachers using the device in a classroom, obviously for privacy purposes, but we do have um, a model teacher trying to replicate a classroom experience in a at home with using the kids, right? Levi, he might be on the call too. Um, Nishant, can you let me know if you're able to hear the audio, right? Starting, could you hear the audio?
No, the audio is not.
Okay, then I need to figure out how AirMeet enables sharing with. Um, there you go. There's an option. Is this good?
Can you play it again?
Was that audible?
No, no, still not. Uh, Maybe if you have an external speaker, that might.
So that's not working, right?
So maybe you can just take us through the.
Yeah, so I can, it's a bunch of things happening over here, right? So one of the things that you can help with is you can basically ask and get questions. As you can see over here, the Levi over here, right, is trying to teach his kids about the speed of light. That the teacher is trying to teach that, and you can ask real-time questions. So you can see our devices over here at the top. You
At the
say,
top.
"Hey Merlin, what's the speed of light?" and you get the response immediately. So that it enables that immediate responses to your questions, right? There's no delay. There's no teacher saying, "Oh, I'll get back to you tomorrow," right? There
Yeah.
is this immediate response in real time.
High
Um,
bandwidth communication.
Exactly.
Some
And
people.
and immediate, right? So you actually have interaction. The kids are not left with unknowns. They're left with knowns, right? And the other thing is it can actually help retrieve resources. Teachers over here have a lot of resources that so the teacher over here has a nice resource about explaining the speed of light, which they want to actually pull up.
Mm-hmm.
So he actually over here said, open my bookmark on the speed of light, right?
Yes.
And then it pulls up this bookmark that he pre-saved for this class, right? There's a lot of lesson planning happening over in the US. So you can plan your lessons, you can plan your resources that you want to use, but you don't have to be stuck near your laptop. You can actually be with the kids and actually be pulling up this information. And teachers want to use all this because you can clearly see that kids are more engaged when you actually have such resources. But unfortunately, that also would require them to be stuck at a corner in the classroom, but not anymore. And they have these bunch of other tabs that they open, browsers and everything, and just navigating through them, they again have to go back because they keep these resources open. They have to go back and again keep pulling things up, right? Not anymore. You can actually use this the multimodality or side of things, right? Not just voice, but you also have um, the remote side of things to actually help you navigate through your browsers. So over here, the teacher is trying to
Mouse.
use the Promethean board that enables you to write things on it as well,
I
and they're
see.
trying to figure out what is the speed of light in miles per hour when you know the speed in miles per second. So
Mm-hmm.
it's a math problem. You need to multiply it with 3600. It's a big math problem. So they decided to ask Merlin instead of actually trying to solve it. Then the kid actually says over there, let's ask Merlin. And they just ask Merlin for the question and it shows the visual response.
Very interesting. So to just quickly deconstruct the components that are there, there's this hardware which is taking in both the sound, our
Yep.
voice, and maybe images, and then there's a system running on the monitor is standard, is it, or you have a dedicated monitor?
It is it's teachers usually have a monitor at home and this device just plugs into the thing. I'll talk about that, the flow of messages a little bit and the components a little bit down the line, right? But just wanted to see over here, in fact, the kid over here decides to ask Merlin. The kid says, you can see he gets up and says, hey Merlin, what is 186,000 times 3,600? And he gets a response, right? And then now they know what it is, right? So it's enabling interaction and more communication during the classroom as well, and it's just more involvement in a classroom, right? And you learn with involvement, you don't learn with lectures, right? So that's
Yeah,
something. So
I mean, just to put in
mhm.
different way, we have been stuck for several decades the very primitive form of communication with computer systems, and it
Yeah,
is
there's
high
this
time
recent thing
we
that
do an
we've
upgrade.
exactly we saw this recent thing that shows about how technology changed from 1800s to 2000s, but a classroom didn't really change. A classroom is still the same, as in, and the way you teach is still the same. There's one teacher lecturing the students, right? In most parts, it's still the same. But shouldn't that be changing? Shouldn't that be changing? It should be more interactive, more in real time, not the teacher saying, "Oh, it's not in the textbook. Let me pull it up later on." Right? That should not be the way it is, and this enables that, right? Without having to uh, really disrupt the current flow of class, right? It can just pull up and then continue the way the teacher wanted to continue the
And
class.
yeah, and a one step back question would be, uh, people even 50 years back, maybe 30 years back, did realize that classrooms are stuck in past, and there's so much technology that's being developed in speech vision research has been around for a long time. But a concerted end-to-end solution. Have people tried that in past? Uh,
Um, no,
have they
they've
failed?
been
I mean, I could guess that there would be many reasons why they failed, but yeah. So, do you know about
yeah,
history?
they've been that's a good point, right? They've been so tech has come to the classroom. It's not like things tech did not come to the classroom, but the meta problem over here is that tech is supposed to make life easier, but each and every tech that came in is trying to solve one problem
Small
about
piece.
hundreds of things that the teacher is doing, right? Like teacher does 100 things. Here is a problem that helps you to, like teacher does assessments, right? So Kahoot, for example, comes and says, oh, here is a way for you to do assessments better. Amazing, right? But then over time, hundreds of such things came up. There is no one thing that really helps you navigate your workflows. I mean, so many workflows
End
that you
to
do in a
end.
classroom, right?
Mm.
Exactly. That just helps you integrate into the classroom. That I believe that's the reason this digital assistant is the first of its kind, right? Trying to help teachers in a classroom. Um,
Right.
build purpose built for a classroom. So digital assistants exist, right? But making it for a classroom for teachers has its own challenges, right? And that's something that we will the basic idea behind this, right? Just want to reiterate that we have an outstanding team. The mind behind Merlyn Mind, right, is an outstanding set of folks who've been doing amazing things across this pipeline, this voice pipeline that I'm going to talk about next. I'm just being the voice behind it. So thanks to everyone. I'm taking this the opportunity to thank all of those guys. Um,
Yeah,
and this is
and at
the
this moment,
yeah.
the audience is relatively quiet. So, if you have any questions, please type them on the chat box, and we'll be very happy to answer them. So, just feel free to throw in your questions.
Yep, I'm going to pause over here just before because we go into the details of the exact stack and things of that sort, right? So 5 seconds stop. Any questions? Otherwise, I'll.
Yeah, so
Um,
please feel free to ask questions. Uh, uh, I guess Aditya, you can continue. There are no
okay,
questions
cool.
right now, but maybe they'll
Yeah,
come.
sure, absolutely. Yeah. So again, this is the overview of what I want to discuss a little bit today, right? To just share this. Just want to explain the typical voice assistant architecture. What are the different components that are required? Just as an, to name them, right? Four major components are your wake word detection, the voice activity detection, the ASR, speech recognizer, and the natural language interpretation or understanding, right? These are the main four components that exist in such a typical voice stack, right? I'm going to emphasize on three of those. I'm not going to talk much about the voice activity detection besides just explaining what it means. Then we talk about how we've enabled Merlyn in our first product. We call it Symphony Classroom. That is the one which you saw in the demo, and how that side of it brought in a little bit of more challenges because it's a hardware component. Some of the microphone algorithms, right? Just mention those a bit, share some pilot feedback that we've been getting, and then wrap it up with some takeaways. That's something that I wanted to do. Okay. Unfortunately, you might not be able to hear this either. So I just wanted to give an example of what a typical query is, right? When you're trying to talk to a digital assistant via voice, right? I can explain what this is, right? Over here, the user said, "Hey Merlin," and then said, "Volume down." So just wanted, so this is the flow of things. So this is how you're interacting with the device. Now think about an individual. I might be sounding too simplified right now, but the mapping that I usually, it really helped me at the start is that if I'm trying to interact with another individual, what are the things that I do, right? Like I call them out, say, "Hey, buddy," and then I say, "Can you do the following?" Right? This is how humans interact, right? And then what's happening in my head if someone is calling me, I turn, you got my attention, and when they request their command or whatever that is, command or request, when they throw in their request, I listen first, then I transcribe it in my head. All this is happening in our head in real time, right? Super fast. You put some understanding to it, and then you comprehend the command. That's exactly what's happening over here, right? This is your wake word recognizer, right? It first recognizes that the command is "Hey Merlin," right? The wake word is "Hey Merlin," which is trying to get your attention. You're trying to call, "Hey buddy," right? "Hey Merlin." You start listening. Then you actually get your wave file that is, corresponds to your utterance, in this case volume down. And then there is also a notion of figuring out when to stop listening, right? Because you can't keep the listening microphone open the whole time. When things end, we need to stop listening, right? Closing the microphone, and that happens via the voice activity detector that I was referring to, right? It understands when the voice activity has ended and the command has ended, and I should stop listening, right? And then this particular command goes through your ASR, which I'm sure most of us is aware of, right? The speech recognizer, which transcribes it into a text component, in this case, volume down. And then the interpreter uh, is the one which understands a natural language into a structured command. An unstructured text command, text utterance gets a transition into a structured command, which it's something that the um, downstream components can actually process, right? Like volume done implies that the goal or the intent is to adjust loudness, and you want to reduce it, not increase it, right? And that structured message is what the downstream components can actually um,
Process.
process and actually can take the appropriate action, right? So that's this is the typical voice pipeline, right? These are the main four major components.
Okay.
When you actually bring in additional dialogue systems, right? You would need to have additional components over here, like a dialogue manager, right? Context holder and things of that sort. But these four are inevitably needed in a voice assistant, basically, right? You need to recognize the fact that you are getting the assistant's attention. You need to get their attention. The assistant need to know when to stop listening, um, and you need to transcribe it, and then you need to comprehend it. These are the four components, right? Uh, for three of those, not all, the goal is just to explain what it is, right? Some challenges that arise in these problems, because they're not new problems, right? All these things are well studied in literature, right? Wake word recognition is well studied in speech and speech signal processing, right? It's a well studied problem, all these, right? And even natural language, we know it's been there forever, right? So just trying to understand what it is, explain what it is, some of the challenges that we faced. I won't be going into the details of how we solved it, but I'll be sharing our results at the highest level, right? And so that we are aware of what's happening, right? So, any questions before I go into wake word detection? Cool. So wake word detection. So it's a
So I
if you
think
go
that
by,
there's a
go ahead.
quick question. Can the wake word be changed in the case there is a child in the class named Merlyn?
That's a wonderful question. I don't know if you can see me, but I have a big smile on my face. That's because that is one of the things that when I talked about some of the pilot challenges that we faced, right? This was one of those. How do you resolve the situation? There was no, I mean, we chose the wake word in a way that it's not really, likelihood of a kid being named Merlin is very unlikely, right? At least in the US. But we did find very similar words, right? Like Evelyn. So when the teacher was saying, "Hey, Evelyn," right, it sometimes does trigger, right? And that's something that we've observed in practice. That's what I was talking about. So in when you write this research paper on wake word detection, you don't care about those things. When you develop a model that does wake word detection, you don't really realize those things. But when you start making it a practically usable thing, that's when these challenges arise. And for us at least, the solution has been the multimodality side of things, right? We also have a remote, right? So you can mute the microphone and actually end up using the push to talk feature on the remote, right? It's been a very low percentage of teachers in the pilots that have actually faced this, but in those cases they acknowledged it, people know about it, and they started using the remote to trigger the device and not actually say, "Hey, Merlin." But that's a very good question, right? That's actually something that we faced in practice. Um, we do have the option to change it, and that's something that we will be rolling out. Eventually, it's a part of the roadmap. Right now, we either have "Hey Merlin" or "Hello Merlin," right? But Merlin is our keyword, our wake word.
So in wake word detection, I guess identify exactly the wake word, nothing else is the biggest problem, right?
Exactly. It's a binary detection, right? It's not it's different than the speech recognition in that way, right? Because you're not trying to transcribe the whole thing. All you care about is, did the user say, "Hey Merlin" or not, right? So that you don't, and it's just a binary detection problem. It's also sometimes referred to as small vocabulary speech recognition task or keyword spotting, right? In this particular field, it's also referred to as keyword spotting. But this is the gateway to the whole interaction, right? So it's a trigger for more complex signal processing tasks, right? So this fundamentally cannot be poor, if because this is how you interact at the first with the device, right? You can't, again, there are two kinds of things. We don't want the user to continuously keep yelling, "Hey Merlin, hey Merlin, hey Merlin," and not being heard,
Yeah.
but we also don't want to randomly conversations pick up false alarms, right? False triggers, and that's going to disrupt the classroom. Understandably, things like Evelyn, Merlin, kids having that names is okay, that if it gets triggered, right? But we do not want false triggers, because that will just disrupt the classroom, and teachers hate that. Of course they hate, because they've been putting so much effort into having a good class, and this is just going to trigger and disturb the whole classroom. Additional challenges, right, with the wake word detection typically is that they be, when people talk about a detection versus a detection problem is just a binary detection. It's not multiple classes. Why do you need a lot of resources? So this, by definition, is expected to be run on very limited resources, because I have to use my majority of resources on your system for my downstream speech processing tasks. So it's already constrained on the amount of resources that it can run. And the way it typically works is that, which is for almost all speech processing things, is there's the whole first block of converting the speech signal into an appropriate feature representation. And this is the typical block, right? You have the speech signal, which is a time varying with amplitude. If people are seeing this for the first time, which I doubt is going to happen, it's basically representing your amplitude of your speech over time, and this is the time domain signal, right? And what's done is typically it's converted into the speech features. And one very commonly used speech features are called Mel frequency set strum, MFCC, right? Their coefficients, right, which get which is like a short term for your transform, but in a different domain. If you heard of these things, it'll be easy to understand. But basically, it's a feature which richly captures your frequencies at each time domain, right? At each time instant, what are the frequencies as part of your signal? And then you have a bunch of these speech features, right, with different accents and different um, um, you know um, different locations, different demographics, right? And that is what is used to train your neural network to learn to say the appropriate classification between um,
There's
the
another
keywords.
interesting question.
Uh-huh.
Assuming, do you assume that the model is tuned to the teacher's voice and not as sensitive to students, or is that
That's
just a factor?
uh, we have tuned it to be adult oriented, right? So it's adult voice driven. It doesn't trigger with children voice. But one of the challenges is that it has to be more personalized. There's been a back and forth on that. Again, part of the roadmap, right? How do you make it more personalized to a teacher? That's another challenge, right? But in the US at least, you have a lot of guest teachers coming in, right? So when those guys come in, how do you enable using of Merlin, right? Because we don't want it to block it off just because that particular teacher is not available. But there are ways to do that. This is referred to as personalized models, where the teacher, um, when it's onboarded, the device is onboarded, it works for every adult, right? But if they have the option, I mean, they have the choice to actually personalize it by giving some training data in real time, right? They can enable this feature in the future, right? And say, I would like it to be only triggering for myself and my voice. And then they give a few examples, and then it gets tuned to only their personalized model. That's typically referred to as personalized wake word, right? Which you might have experienced with the other voice assistants too, right?
And there's another question from Sandeep, which
Mhm.
is probably going one step ahead. Classrooms are typically noisy. Did you have to do any source signal separation?
A lot.
Talk to,
Yes.
are you going to
So
talk
this
about this signal separation?
a little bit. Yes, I'm going to show some. Again, we can't hear, but I'm going to just mention that when we go to the device side of it, right? We are now talking about Merlin as the assistant, which is independent of where it's residing, right? So it's the stack itself is independent of any audio signal processing done before the signal is coming in, because it doesn't matter what microphone you use. All these examples, these modules are independent of where they're residing, right? Where Merlin is residing. But once you start thinking about our first product, which is in a classroom, the device has its own microphone and things of that sort. You actually have these additional things that you're talking about, which is how do you tune the device to actually ensure that it's appropriate noise removal is happening, right? Having said that, this is something that there are other aspects of the software itself that depend on the fact that it's a classroom, right? Because your model has to be robust. Even after noise removal, it's not 100%, right? Your model has to be robust in the background noise being what people refer to in a classroom as classroom noise or babble noise, right? Because there's a constant babble happening across among kids, right? So we should ensure that our models, whatever we are developing, right, with detection, ASR, and even the VAD, right, voice activity detector, is robust in such noise models, right, because it's a classroom setup as Sandeep brought up, right. So that's something that yes we have done for these models too, and specifically for the Symphony Classroom device, we had to do some additional um, um, signal processing stuff as well, so signal source separation and noise removal stuff, beamforming too. I do have something that I'll mention that on that, right? But just to go, any other questions before I continue? Okay, so again, how do you evaluate, right? As I was mentioning, the biggest challenges about wake word detection and how you evaluate is um, there is no single universally reliable method that works in every place, right? So you can't just say, here is a solution, it works everywhere. You need to develop your solutions, you need to play with your models, you need to tune it to your particular problem, right? And that's something that we had to do. Again, on-device solutions are expected to be small footprint, right? But that's the trade-off. Smaller footprint, you typically have a lower accuracy. So you'll have to work further in optimizing and ensuring that the input is really neat and well tuned to the model, right? And of course, as I mentioned, the biggest problem is accidental triggers. And this is an interesting paper that tried to compare the different, wake words that get triggered and different assistants right now, right? With different of these words, and compare it with by just running these TV shows in the background, right? And see if any of these will just trigger it, right? These are accidental triggers. Nobody is actually calling the device. This is just people just running this on the background and see if it'll trigger these devices, right? And you can see there are two sides of it, right? Gray and green. Gray is whether the device just triggered it. But as you'll see in the next slide, most of these devices have a two-tier approach, something that we adapted as well, a version of it, right? is that a customized version of it is that they have this local thing that triggers first, but they also do something called a secondary validation of it, which is typically on the cloud. And you see that that makes a difference by ensuring that it weeds out all these false triggers. You still get false triggers, right? Like for 13 days, you actually get 8, which is very, very understandable. Um, but you can see that if you did not have that secondary thing, look at the number. The gray is significantly more for most of those. But you see in a few cases, right, like the Computer Eco, Amazon, and Google, right, you actually have the green one being more. And that is understandable because potentially these words are something that are used in practice, right? They become a part of the daily usage, right? Amazon, Eco, and Computer, right? So it's understand Computer especially, right? It's understandable that when you send it through ASR validation on the cloud, it'll transcribe and say it's Computer because they're high likelihood words, phrases. So that's something that is a known problem. All these are known problems with wake word detection, right? We have accidental triggers. So what is the solution methodology that we've adapted? Any questions before I proceed on this? Okay. So you see this block audio processing, right? This is what I was talking about as something that happens for example, Sandeep's question, right? Like signal source separation, noise removal, and things of that sort. There's an audio processing block. Then there is this strict detector or a more one-off detector, right? It's like a perfect hey Merlin, right? Then you just trigger it. Don't have to do any additional cleanup, right? This is to ensure that there's a high detection accuracy. But to ensure that um, um, there are no false triggers, we have this additional loose detector things, right? That we actually try to clean up via an additional audio processing block, which again is something that we've developed for our solution, and hence I had to put it as an audio processing, not really in the details. But then further, an optional ASR, because this could be just one of the blocks, right? This is not necessarily the only way to do things. People have come up with different ways of doing things, the solutions, right? These are all potential wake words, and then they go through another validation, and that validation could be done by a different model using a different architecture, right? A neural network was an RNN versus a CNN kind of a difference, right? Because one of them is good at removing false triggers, is much more strict, right? And the other is more acceptable to sending out any potential false, any potential wake word phrases, right? Another is to use ASR, as I mentioned, right? Um, and sometimes you use the same model but with a different uh, parameter value. And that's something that we've observed, right? Like when you have these detection problems, right? There is always this trade-off between missed detection and the false alarm. If people coming from statistical signal processing background will know about false alarm probability and misdetection probability and ROC curves, and people coming from statistics background will know type 1 and type 2 error that I'm talking about, right? You don't want to have errors. So you have a trade-off, and there are parameters in your control that enable such a thing. So even as a part of our experiments to actually ensure that we have the best model in the field, we've done very similar things. We first have to do an offline parameter optimization by just running through multiple curves, multiple models, like something which will look like this. Again, I've hidden the information on what each of these models are, but then the idea being that, right, which you actually plot different models, get their performance, right? The idea is to be as close to this point over here, right? And you pick a threshold, which is a trade-off. When you go more, you go more towards lowering your miss rate, you might have more false alarms, and vice versa, right? Um, and the way these experiments typically run, as an example, is that you have a speech speaker, which is the one which is uttering the hot word, saying hey Merlin, or Alexa, and things of that sort. And there is this a noise speaker, which is recreating the background noise, right? For example, we've done this in multiple scenarios, right? We've actually had silence where the noise speaker was off, right? And we've compared the performance of a detector, right, which is like 100% in our case, with varying SNR values of the speech, because we need to look for different volume levels of the speaker, right? When they're low, saying "Hey Merlin," versus being loud, "Hey Merlin," right?
And
Um,
so,
I,
so you're basically talking about the data generation process for training your model, right? You want to capture
This is
various.
more for the evaluation itself.
Okay, this
This
is for
how
the
we,
evaluation.
because
Not
correct.
ideally, well, if you have all the data, or if you figure out that this kind of data is not handled by the current model, you would go back and add that data.
Right.
Is that the right?
So there are few things right over here. I mean, there are if you have lots of data, right? If you have enough people yelling "Hey Merlin" and not "Hey Merlin" stuff, right? You could create a model, right? You could create a model, a neural network model, but that is again, that's where the difference between theory and practice comes in, right? That's a theoretical model that you've developed, right? But when you evaluate it, you can always evaluate it by just running your test set through the model on your machine, right? And that's when you get such plots. But that's not how that won't work in practice, right? We need to actually
Yes.
see the effect of it in practice, right? And that's this experimental setup is trying to recreate that in practice, validate the performance of it in practice.
So a lot of the field has moved towards synthetic data creation, where they try to capture.
Right.
So I'm trying to understand what is the. I mean, is a synthetic data generator for real life audio,
Hmm.
specific to suppose just wake words, not in general. Is that well defined? I mean, are the you have to create the kinds of background that can you fit in those parameters and just cover the whole grid? Is that
We could. I mean, the thing is, synthetic data really helps to train, right? But it synthetic data has been again more so in the recent past, right? Has exploded a lot, right? What people have done with synthetic data. But it's very difficult to replicate the reverbs, for example, in a classroom, right? You actually you see you set up these an open area, open era, right? Open classroom versus a closed classroom with furniture and things like that. It's difficult to optimize that with just synthetic data, which has a few parameters, right? We've done that. We've done three sides of it, right? We've done creating the data, right? Training the model on the data, evaluating it on that data on a test set which is generated by synthetic, right? But then we already saw a difference between the third thing and actually doing it in a lab experiment of this sort, right? The things make a difference, right? Synthetic data has helped tremendously, but it hasn't still replaced, at least in our experience, with actually doing an experiment of this sort,
Mhm.
right?
so
Running go
yeah.
ahead.
So what I hear that there are some aspects of synthetic data generation that are not covered by synthetic
No, I mean,
real
yeah,
data.
it's not, yeah, real data is real data.
Right.
um,
And to
that's the
replace
reason.
that, what is the simplest, what is the easiest thing to, I mean, okay, the obvious solution is to go out and capture real data, but that won't scale. So is there a intermediate point?
So that's what we've been doing over here. I mean, is that for training or for evaluation, right? Again, the two different things. The training, the best thing is always to still collect data, right? But for evaluation, you can go around it, right? Rather than making people actually test it out, we've been able to replicate it using such a setup, right? Again, as close as you can. Have an experimental setup where you actually have a speech speaker, which is throwing out these voice utterances with a background noise speaker actually having this background noise continuously. But for the microphone listening to it, they both come in as if it's in a classroom, or because you're sitting in this environment, you're in an environment with this noise continuously playing in the background, and one speaker with a particular SNR value in this direction trying to wake the unit, right? Or wake up Merlin. So we could replicate parts of it this way, right? And that is closer to what we've seen in field as well, right? When teachers started using it in classroom, this is reasonably closer to what we expect in a classroom.
Yes.
A bit closer, right?
So,
Um,
there's a quick question. Once the device
mhm.
has been used in a classroom for a few hours, you have enough samples of the teacher's voice. Can you use that voice data to fine tune the models? You can also do a
Yes, we can.
speaker identification to reduce.
Yes, yes. Actually, both are wonderful questions, right? We can actually do both, right? Speaker ID is along with the personalized wake word, and the wake word detection is your personalized wake word in a way, right? And the second and the first question, right, which is can we collect this? Again, theoretically, yes. Practically, there are other implications, and one of the big thing is being privacy, right? We can collect the teacher's voice, but the reality is the device won't be used with just the teacher in the classroom. It will be used when the kids are also in the classroom. So what we ideally need is the device sitting in the classroom the teacher teaching the class, and then you record it. But that's not acceptable, right? There's a lot of privacy concerns. In fact, for us, one of our biggest solutions is that we do not collect voice data. The voice data doesn't leave the device, right? It is processed on the device, and the end. It dies right there, right? We do not collect data. We do not have the voice data with us, and that's because we respect the privacy of the teachers and the students in the classroom, right? And that comes with a challenge, but we've acknowledged that and we've taken that call, right? Because we want to be supportive to that. So
That's a very interesting decision, and very, you're, you know, you're constraining yourself a bit to, and with the
that's
belief
true,
that
but
you can
that's
still solve it.
but yeah, exactly. But again, that's the trade-off, right? We are going to have a nominal solution is not going to have voices saved, right? If the teacher wants, to be involved, that's a different thing, right? But in a classroom, we do not collect and save data. That's the bottom line, and that's what we are on right now, right? That's our privacy policy.
I
That's
see.
what we are.
So this is just,
That's again,
yeah,
that
go
is the
ahead.
difference between a voice assistant and a device in a home or in a non-classroom environment versus classroom environment. That's one of the biggest challenges. We can, again, GDPR, there is COPPA, FERPA, and multiple of these compliances, right, which rightly stop us from doing that, and we want to be supportive of all those compliances.
I see. So that's interesting. So just to recap, both the wake word detection and the ASR happens on that device, and it has to finish in real time. And so
Yep, yep. The voice doesn't get saved. Verifiers don't get saved at all, right? So we don't have access to anything, which is also the reason we don't have any of these demos and whatnot, right? It's more about respecting the privacy of the classroom teacher and the students. So which is why before we go into the field itself, we'll have to do all these optimizations that we can, right? Like figure out what is the accuracy, ensure that there are no false alarms happening in a 24-hour time period, right? Like in our case, we saw that there's zero false alarms, right? And then a good thing is 34 of them were ignored or rejected because of the secondary validation that we have, which means if you did not have this other path, right, they would have all gone through as false triggers, which means that's a very significant and important part of the whole solution that people have been adopting across the board, right? Everyone has been acknowledging that as a required part of the solution, and for that very reason. Any questions on wake word before we go to the speech recognition part of it?
so there's a good question. How much of context do you maintain, or is each interaction independent?
For the wake word, there is no notion of a context because the user, they have to get our attention, right? And the moment the utterance ends, they need to get our attention again because we, as again, by definition, are not listening unless and until you trigger it, right? You call up and say, hey, listen to me, right? So there is no notion of a context for the wake word, but for downstream processing, right, as I was mentioning over here, right? For each of these utterance, for transcribing it, you could actually start, and for natural language understanding, you could have contextual information. And that's something that we use for optimizing the whole pipeline, right? As the user actually, as the person just asked, right? Yes, context is something that enables us to have a better processing of the input. But more so not in the wake word, but in the speech recognizer and in the as part of the language model, right? Or your hypothesis search, right? And your downstream processing of understanding. Oh, which command do you have to act on, right? Or who should act on the command, right? Is something that context defines.
Yeah,
All
please.
right. Go ahead. Moving forward to ASR, right? I mean, this is the one of the most studied or understood problems in the whole speech paradigm, right? But just to define the simplest, again, the simplest ASR architecture, right, is you get your signal, you have your processing and feature extraction. This is very similar to this module is always common in every speech signal processing task, right? What typically happens in the ASR models, I'm pretty sure most of you are aware of it, but just for the sake of completeness, you have these acoustic models and language models, which basically, the way I think about it, is that the acoustic model traditionally tries to understand the phonemes in the utterance, right? You actually have the signal, it tries to get the phonemes, right? And the language model and eventually hypothesis search tries to figure out what the phrase could be by looking at multiple combinations of these phonemes
Smaller units. Yeah. In the
and then
composition.
having a score corresponding to it. Exactly. And that depends on the language model. So it figures out, understands what language it could mean. And a good example that I usually think about is silver play, right? If you just get an audio signal saying silver play, right? And the feature extraction is done, and then the acoustic model maps it from the signal to the phonemes, you get these phoneme syncs, right? All the stuff. Now the language model defines what it means. If I put in English language model, it could actually come up, it will come up as silver plate, right? Or silver play, right? Silver play. Whereas if I actually put in a French language model, it will come up as silver play, which is a French phrase, right? So that's where the language model is trying to put these phonemes together and actually make a phrase which is appropriate based on the language model scores. Because the language model, if it's a French one, actually has a more higher score for silver play than silver play, right? And vice versa for English. And although I'm using language in this example as real languages, the language model could be anything, right? Even Twitter phrases have a different language model than research papers, right? Because you write it in a different languages. The bigrams and the trigrams, which make it up, actually have a different uh, probabilities and likelihoods, right? And different scores. And that's basically the idea behind what happens in a typical ASR architecture. And it's very interesting to just take a second to figure out how to see how the ASR systems have evolved over time, right? Um, at the very beginning of ASR systems, they were really small vocabulary. We recognize these four things, right? And which of the following did you mean, right? Even in the automated systems that talk about, right? Oh, they say, oh, can you please say which one, say one or say two, say three or say four, right? So basically, they are trained to recognize such a small vocabulary. It's a constrained task, trying to do which among the options it is true. It's expecting clean speech, a little bit of any other background noise, and it gets messed up, right? And it was traditionally more read speech, right? You read. So the language expected is of a written language because you're reading a written language stuff. And it was very traditionally for only a single language, right? The way things evolved, right? In the middle, it was more about a large vocabulary, right? That was what large vocabulary and language models have come up, right? Which you can open-ended, open domain language vocabulary can come up. It's a flexible task. You don't really have to be, but it's still a task dependent, right? Within a task, you'll be constrained. Um, Again, carefully spoken, otherwise it fails, which is most of the speech systems even now actually fall into the middle scenario, right? They do multiple languages. But where things are going forward, right, is where the exciting part is, right? It's a huge vocabulary. People are aware of everything right now. A new word comes up on the internet, you're expected to know when I speak it out, and the speech recognition system is supposed to transcribe that. And the vocabulary is just growing up, right? And you need to understand that in terms of every possible way, because same words starting to have new pronunciations because people think it's cool. So we need to be aware of such as part of your acoustic model and language model in your speech recognition system itself. Freestyle task, right? It's like it's open conversations, like we talking right now, right? It's not necessarily have any structured language to it, right? It's something that's a freestyle conversations are happening to be transcribed right now. And noisy far field speech, something that we faced in our problem as well, right? In a classroom setup, it's noisy, it's far field. You are not right beside the device, right? Or wherever the microphone is. Far field is a different ballgame altogether, right? And it's spontaneous speech. You're not reading, you're not planning anything. It's just happening right now. And the best part is, which I love, is the mixed languages. Multiple languages is one thing, and mixed languages is the other thing. People talk about English and whatnot, right? Like in the middle of your language, you change into a different. In the middle of your sentence, you change to a different language, right? So it's not like you can expect different ASRs for different languages. You're expecting the same ASR to do both. So the language model is expecting someone to actually say silver play, right? And expect to know that the first one is supposed to be the French silver play and the second is supposed to be silver play, the English one, right? And super difficult problem, right? Because that itself has an additional challenge over there. And that's the way ASR has evolved over time, right? Any questions?
First, I'll just acknowledge that that was the quickest 5-minute introduction end to end ASR. Yeah, thank you. Yeah.
Sure. Um, and so when we talk about customizations, right? At least I'll just take a second to explain what we have over here, right? This is something that really helped us, and I hope will help anyone who's actually trying to use or figure out what's wrong with my ASR. You take an off the shelf ASR, start using it for your problem, right? The challenges, right? The language that it's trained on, this open domain generic purpose ASR, right, is going to be a different than what you might be using in your particular use case, right? Um, the language that people use, yes, there is a choice to change the language model, but it might still not be appropriate for what you are trying to use it for. And in general, right, the general purpose ones have limited control over changing the language model for every utterance or things of that sort. There is a notion of context, but it really doesn't do beyond just weighing your weights a little bit here and there, right? But so here is a scenario that happened. You took an off-the-shelf ASR, you used it on your task, and you're getting poor results. How do you figure out what's the problem, right? Like, what do you do, right? And that's something that we've learned, right? It's like you have your data set, you have evaluated it, you have the ground truth of that. You do something called the word error rate for the transcriptions. And now what happens, right? Like every ASR nowadays, almost every, right, comes up with multiple hypotheses as outputs, right? These are multiple alternatives. So what you do is you actually try to look at the top alternatives word error rate with your ground truth. If it's low, well and good, you have no problem, right? If that is not low, if it's high, we want it to be as low as possible. Then what do? You actually try to look at the word error rate for the top K. Look at the top 10 utterance, the outputs of your ASR and see the best word error rate corresponding to the top K, right? Looking at the top K alternatives. If that's low, the way you fix or your customization solution is to think about some kind of a hypothesis reordering. Use your context, right, to reorder your alternatives, also referred to as hypothesis, to have the appropriate top one word rate, and that's the way you debug your ASR or customize your ASR. If that is also high, even if the top KSR is high, which means that none of the alternatives are matching your ground truth, then you try to do something called the phoneme error rate. Try to transcribe your utterances, the outputs, into phonemes, right? Which is like grapheme to phoneme transcriptions. There are
Yeah,
many GTP
characters and
models.
phonemes. Yeah, I assume
Exactly.
the audience is familiar with phonemes, which are the smallest units of speech, audible
Speech,
speech. Yeah,
right.
yeah, please.
So you do that for both the ground truth and the alternatives and look at the phoneme error rate. Now that tells you very important information, right? If that is low, it means that so if you go back to this, right, that means it over here things are all right. Things are failing over here, which means that you have to work on tuning your language model. It's getting the phonemes correctly, but it's not doing the appropriate transition from phonemes to your
Words.
eventual words, right? That means your language model that you're giving it to the system is not accurate to what you are actually looking for. And if that is also, even if your phoneme error rate is also high, fundamentally things are messed up over here, right? The mapping from your signal component, which is your with your wave file, right, and the speech features to the phoneme is not accurate. This is not something that might not happen, right? This is not a rare event that I'm talking about. This would happen if your acoustic model itself is not accurate, which means you trained it on one particular accent and you're testing it on a different accent, for example, right? Like you're using a US model of acoustic model of your speech recognizer, and you're testing it on the Indian accent, right? For example, then it is fundamentally going to map your speech units to a wrong phoneme because your pronunciation is different. So what you need in that case is a tuning of the acoustic model itself, and that's much more difficult of a thing to do because you need WAV files to actually do that. So if you're looking at language model tuning, all you care about is having the appropriate language and having just the text. It's only on the text side. You can do the language model tuning by just having the appropriate text inputs, right? Text stuff. But on the acoustic model tuning, you need fundamental wave files as well. So that's the kind of way we've been doing things, right? So keeping that as your debug thing, we've developed a domain-specific solution that enables reordering of these and customized to actually have improved ASR performance, right? Any
Yeah, so,
questions?
so the decision tree, debugging decision tree it's a very useful tree there. I'm not sure, is it, it's the first time I've seen it written on the slide. Is that, are the books that have that tree, or you do it
No,
for?
no. This we've done it internally, right? We've been using this.
Yeah,
It's
it's a
ours, right?
very
So
insightful way of debugging. Eventually, every speech engineer, I think, learns that you have to debug in these stages, but
yeah.
it's very nice to
Exactly.
have.
It's just you're going through the pipeline, right? So it's like in this the architecture, right? You're figuring out where in the architecture things failed, and just putting it into this picture, right? It's something that really helps debug the use of ASRs. Um, and and uh, um, and again, how did this help, right? Again, evaluation typically of ASRs, which we don't really agree on, but using this for the slide, is on the word error rate, right? And this is something that we've done in two parts, right? Because of a data set that we had, right? We had a smaller data set that we started with when we had the idea of trying to do this. We wanted to test on this idea, and then we collected a bigger data set and evaluated it. It's 1,000, around a little less than 1,000 wave files, the first data set, right? And what we've done is just get the word rate as a default ASR output. Mind you, this default ASR actually has our customized language model in it, right? And then when we saw the word rate, it was around 10.69%. Typically, we want it to be around, below 10, preferably in practice, right? Because the downstream systems can actually manage the 10% worth of error. And just by doing this debugging and understanding the customization requirement, right, we were able to drop it down by 4%, and that's a big jump in reduction of the word error rates, right? So we went on this idea. We progressed on this idea. We went for a larger data set, right? We evaluated it in a bigger manner, and for almost 13 and a half thousand wave files, we see the same observation, right? Things drop by around 4%, and now come within your acceptable numbers for real practice. But just using the default off-the-shelf system, right? I'm not going to name which system it is, but it's one of the most prominent speech recognition systems, right? With appropriate input as language model, we still cannot get the best. We can do better than that, right? That's basically what it's showing.
So that decision tree guides you in getting in first figuring out where the error is, and then getting the appropriate data also. So you have to get WAV
Yes,
files
yes,
versus more text, right?
that's right. Yeah, that's absolutely right. It tells us your actions, right? What you have to do because of what you're seeing, right? Because one of the biggest things that we see is you test it out and it's terrible. Now what? What next, right? And that's an unknown. And this allows you to figure out what your next steps have to be, right? Appropriate steps to be done. What you already have versus where you want to go is this gap, right? The
Yeah.
path is what this allows you to get to.
And as the data changes, does your test data on which validation data also change?
No,
Or,
I would keep it the same, right? Because the whole idea is that your performance, or you are not seeing the test data. Basically, you should not be uh, um,
yeah,
tuning things to the test data, right? In a way,
yeah,
but
but
this helps you to figure out what the fundamental problem could be, and you're making a change on your validation set itself.
yeah, but with incremental addition of data, it could also be that you get in some new variations in your train
True.
data, which your model knows, but your test
The
is not.
generalization side of it, right? The generalization side of it. Yeah, yeah. And that's important too. I mean, that's the whole idea about the AM tuning example, right? You're seeing a big mismatch between your training data and the test set, or your use case set, right? You use a model that is for one accent as an example, or another side of it is gender as well, right? Or age, right? You're using a speech recognizer trained on adult speech for a children's ASR, right? For children, doing ASR for children speech, right? It's going to be bad because and it's going to be bad even in phoneme error rate potentially, right? It's going to be high because it fundamentally needs AM tuning. It cannot get better without wave files, right? So it at
Right.
least tells you what you need to do to get to where you need to go.
Right.
That's basically the and again, although I did say this is the typical ASR architecture, things have changed, right? People are now doing end-to-end systems. they don't really have an explicit acoustic model and language model necessarily. They do have
Right.
a language model, but sometimes they like some of the deep speech models, right, do things directly from the audio signal to the letter, right, to a character directly.
Right.
They still have to do some hypothesis search to put the characters together as words, but then things have changed a little bit. But fundamentally, you can still use this to debug and understand what you need to do next.
Yeah, and very quickly, has the the separate language model versus an integrated language model? Is there a decision? Is there a what is the SOTA? People have tilted towards the integrated language model, integrated acoustic and language, or they still keep
Oh,
separate.
I think traditionally it's been separated out, right, always. But since these new end-to-end systems have come up, they've been significantly better. But the way I look at it is it all depends on the amount of data that you have, right? If you have huge data, right, sure, you can go to end-to-end systems because they're eventually learning all possible combinations of things, right? Because your data is actually capturing all those. But if you actually have not huge, but the definition of very huge versus big data, right? If you have something like big or large data, not really huge, it might be better to have these separation of components, right? Because it helps you to optimize, use this limited data in the best possible manner.
Mm. Yeah, so very interestingly, your architecture can also evolve as you get more data and as you
True.
debug. So as you get
Correct.
more data.
Yeah, absolutely right. That's right.
Very interesting. Yeah.
So, any other questions?
There are two questions which I have batched them. So just a quick mild reminder that we have 20 more minutes in this session. Yeah, I'm
Hmm.
not sure how much you want
I
to
think we
cover.
should be fine. I think I have around 10 minutes worth of just the natural language interpretation stuff, so I should be fine.
Yeah, so I'm going to batch these. The two questions. One was about wake word. Can't wake word be tuned to have at least have the least misclassification? Can
No, actually, that's a good question for sure, right? Can we actually optimize it to just be misclassification, right? That would be true if you're treating both the errors equally, right? As in, as long as it's a misclass, I don't mind whether it's type 1 or type 2 error. Unfortunately, in reality, in practice, right, not just in classrooms, in general wake word, right, uh, the frustration levels for each of the errors are different. I don't mind saying the wake word 2 times to make me hear it a bit more than it randomly triggering in the middle of the night and saying, I don't know the weather, right? When I'm sleeping and it just randomly triggers and says, I'm sorry, I cannot help you with that, or some kind of a message that comes from the unit, right? Is more not acceptable. So false triggers are a bigger constraint. They have a higher weight of being an error than the missed detection.
I see. And the other question was that about are you using off-the-shelf ASR like DeepSpeech or did you develop from scratch? I think you
That
mentioned something
is,
about that.
yeah. So we did, that's what we tried to do, right? We've explored building it from scratch. But as a startup, when you start, right, as we were discussing before, right, we've learned that the customizations make a difference. And off the shelf, we've developed our off the shelf using Caldi and Deep Speech, right? Um, but then you need a lot more data than what we have, for example, right? So we've recognized again to optimally use the data that we have uh, to build on top of the shelf solutions, right? Use the data for customizations rather than building from scratch. Again, if you have more data, you can build from scratch. As I mentioned, right, similar to what we were discussing about the end-to-end systems, right, Nishant? If you actually have very huge data, do an end-to-end system directly. Similarly, if you actually have a lot of data, you can build an ASR from scratch. But when you do not have, use your data in most optimal manner, which is more on the customizations.
It's very good. Yeah, there are no more questions. We can
Okay.
continue.
So the last but the most important, at least from, I mean, not the most important, everything, all of them are equally important, right? Is the natural language interpretation module, right? Also referred to as NLU, natural language understanding. It's basically trying to comprehend or interpret the given input, right? You actually get a, you now have a text utterance, right? And you're trying to understand what it means, right? It needs to move into a more actionable, structured input, right? Like you got a transcription saying openyoutube.com, right? This NLI module is what is going to transform this transition that and different variants of saying the same thing into a same structured output, right? Which is like you say open youtube.com, or say can you open youtube.com, or you say go to youtube.com. It doesn't matter. Go to YouTube without the .com. All these should map to the same intent, parameters, with appropriate confidence levels, and just whether the action it's an actionable thing or not, right? Here is an example on that, right? Um, and typical elements of such a representation are again dependent on your downstream tasks and things of that sort. Is what is the intent? What is the user trying to do, right? Do we have the appropriate entities corresponding to those to the can you extract the entities and actually map the entities to the slots required for this intents, right? In this case, you can see that all required parameters are present is true because you have the intent of name tab selection goal, which is a goal to a particular name tab of a name web URL, and you have the parameter associated with it, which is opening a browser URL, which is youtube.com. Again, there is no universal representation, right? There's no one way to do it, but there are ways based on what you are trying to achieve. Uh, I mean, traditionally, or at least from seeing from literature, right, we've seen two different ways of doing things. One is more on the parsing based, where you can try to parse the utterance using linguistics, right? Understanding, oh, here is a verb versus this is the structure of the verb. This is the noun, and parsing graphs have a notion of mapping from the noun to the verb and things of that sort. That is one way of doing things, and then from the parsing structures, you can understand the intents and the entities and all those kinds, right? That is one way, and the other more recent solutions is machine learning based way, right? You give it a bunch of examples, and the model learns to map these text tokens into appropriate features, and then build classifiers on top of it, whether it is a what kind of an intent it is, right? For example, and for each intent, you can actually have required entities or slots, which you can again build further classifiers, a hierarchical way of doing things. Uh, what we've again understood is that the best solution is never one. It's more ensemble, right? This is a general understanding of how things work, right? An ensemble is the way to go. So we've, like for example, the different ensembles that you could have is example-based machine learning, parsing-based, just classifiers that kind of, for example, have sentiment classifiers, right? A question, is it a question or not? Is it a, what kind of a sentiment is there in the utterance, right? And then there is so much of a pre-processing that we have to do for these utterances. For example, is something called text normalization, stemming, parts of speech tagging, recognize entities. Sometimes you can have sometimes regex works significantly better than example-driven intents. Something that papers don't talk about in general is because we all want to do machine learning. People always go towards example-driven machine learning intents, but solutions such as regex, as simple as that, right, solve sometimes 50% of your problems, right? So which is why ensemble makes sense. In practice, you can't just go by one solution. That's something that we've learned, right? Actually get the best of all the worlds as much as you can, right? And also another thing is these machine learning systems usually, right, or example based, throw out one intent, right, and a confidence level. But if in a downstream task, depending on what you are, where you are, contextually dependent, multiple intents could be relevant to that particular utterance, right? So it's better to actually map to all possible intents if there is no context information. But if there is context information, you could actually also always provide contextual best intent. But we wanted to make it again, each has its own benefits. For example, doing it a map to all possible intents without having the context allows you to keep this NLU reusable across all domains, right? Keep this as a one solid thing in between, which the downstream units can actually, or downstream modules can actually optimally pick based on their context that they are aware of.
Yes, very interesting. Yeah. The vocabulary of intents, or the set of actions that you allow, do you fix it? Do you keep it? Does it also evolve?
It is ever evolving. It's going to change, and that's where as you enable more, and we're trying to keep in general, an NLI system is going to be as generic as possible, right? But sometimes you have to, which is where the hierarchical comes in, right? At the bottommost layer, it's generic. It's independent of what your downstream tasks are, right? But over at the higher levels, you try to map multiple things towards same action, right? Oh, intent A, B, C mean the same thing, right? And that evolves. This mapping evolves over time because we're enabling more features, more intents are needed, and things of that sort. You map them accordingly. But at the most generic level of the NLU, it's going to be as generic as possible, right? We don't want it to necessarily be specific to a set of intents that we need to act
Yes.
on,
There's a hierarchical model. Yeah.
right? Um, any questions on that?
I think the questions are a little bit. But I'll batch them, and maybe you can just finish
Okay.
these.
Yeah, I'll go. Yeah, we have a little over 10 minutes. So just going towards the hardware, right? We're just talking about our device Symphony Classroom. One of the persons actually asked this question at the start as well, right? Sandeep, I believe, was asking about the separation and things of that sort, right? Here, I don't know, I don't think you can hear, but here is something that we had to do specifically for the hardware form factor, right? Merlyn in Symphony Classroom had additional challenges, which is babble noise in a classroom, right? Like I wish you guys could hear it, right? But over here, you can actually, if you could hear it, is that the primary speaker's audio is heavily dwarfed by the babble noise. In fact, you can't even hear the user saying what they were saying, which is trying to just say, oh, here is a test and something like that, right? It's bad for both wake word and speech recognition if you cannot hear anything. But adding additional, signal processing algorithms to do this appropriate noise removal and things like that, right? Made a big difference, which if you could hear it, right? And even at least in the pictures you can see it, right? The noise, which is all over here, right, is significantly dropped in the noise reduction, right? Using appropriate beamforming, right? Uh, and that's all done on the device, right? It's edge signal processing. It's reduced significantly the babble noise of the kids speaking in the background, and now the user's actual request is actually audible, right? And that makes a big difference, and something that we had to do, not for the Merlyn voice stack, but for the fact that it's in a classroom. It's the fact that it's actually sitting on a device in the classroom in a far field setup.
Yeah, I guess you could extend that tree to add data pre-processing or.
Yeah, that's right. So here is a just final summary of the whole pipeline, right? I mean, or a voice pipeline in general, right? And how we've utilized it, for example, right? Is like you have the signal processing, microphone signal processing that happens. You have the appropriate wake word detection. You have the voice activity detection happening, which is basically a binary classification too, right? Voice activity detection. Is it voice or not? Is it voice or not, right? At every time instant. And then the ASR, right? And then we've added additional things of the domain specific adjustments that we've learned or customizations, what kind of an NLU you understand. These are the different process that goes through, and then the contextualization to application, which I was talking about, right? Because you get multiple intents that are mapped to the same utterance and intents, and then the application makes the appropriate choice based on what has to be acted upon, right? What is your context? As another person actually asked, right? Do we take context into consideration? Again, two ways to do it, and context can be a part of all the voice tag modules, or keep the voice tag modules generic enough, and the application is the one which is going to pick the context, right, based on the context. um, just wanted to any questions on that? I was just going to share some teacher feedback, and then just some closing comments, right? So any questions so far? Any other thing that you would like to bring up, or should I just continue, Nishant? Okay.
Yeah, you
I'll
could
just leaving over here, right? But anyone wants to read, they can read it. But what we've observed is that uh, what I said at the start, right? Teachers have hundreds of things to do. We might feel it to be a smaller issue. Oh, okay, is that really a big problem? It is, because one thing that the teachers don't have is time, right? It's a huge resource for them, right? Apparently, even if they say 5 minutes in a classroom, right, during one lecture, it's 10% of their class, right? Because they have a 50-minute class, right? And that makes a big difference, right? I mean, so this was really a good set of feedbacks that we've received from teachers, right? I mean, they can't, it makes much. It's nice to hear that, right? So going back to the sorry, that's
I'm sorry, I was.
Oh, no, no worries. No, so it's just to going back to the start of this talk, right? When we're talking about personal journey and whatnot, right? Um, right after no, my grad school, right? PhD, I was interested to get into the whole academia and things of that sort, right? When I got this opportunity to go to IBM Research and look at things, that's when it was an eye opener for me in general, right? Because I until then I was all about, oh, I want to, there was one goal to do research, publish, get citations, that mentality. But then none of none of your papers ever published papers get such nice reviews, right? Nobody's going to send a review saying, oh, I cannot imagine, I cannot picture working without this paper, right? Whereas when the teacher comes back and says, I can't picture teaching without Merlyn at this point, is just really good for me personally. It just makes a big difference. So in conclusion, just wanted to share that this things are different between research, development, and product, right? The system, building a system that works in practice is a different ball game than something that works in a lab versus something that works on paper, right? And that's something that we learned over the past few years, right? And then specifically on this, right, on this journey, domain-specific solutions require understanding the domain, right? You cannot have generic solutions expected to work for the domain, for a particular domain. And to speak more about the classroom environment challenges, right? We have noise as an issue that some of you, rightly brought up, right? And of course, privacy is a requirement. As I mentioned, right? Privacy is a big thing to keep in mind, right? There are other issues as well, right? Network considerations in a classroom, right? Which I didn't even go into because there's more on the voice stack. But there are other challenges that we think about. So our approach was to develop an AGI appliance for classrooms, and that's what we've done with Merlyn in Symphony Classroom. This is largely generic tech, and that can be used as solutions across in other environments. But right now, our focus is in the Symphony Classroom as a device, right? And finally, thank you. Any questions, comments? You have my email address, so I'll be happy to answer any other questions or share any other part of our story. Am I on
Thank you.
time?
Well, yeah, so I'll talk about the rush part. Thank you so much, Aditya, for taking us through, end to end, ASR, NLU, and the real life implementation stuff. Yeah, there are few, maybe one or two questions. I've put in a Zoom link. This session 4 stops in 6 minutes. Maybe we can do it here, or the Zoom link. You can join audience, people in the audience, if you are interested in asking more questions. And if Aditya has a few moments, you
Sure.
can join that, and we can just continue there. Or right now, if you have any questions, there was one question about how do you cater to different dialects of English speaking teachers from different parts of the world.
That's a very good question, right? Because it's not easy. As obviously you can see, right? Forget about different parts of the world. We've been seeing again in practice, right? There are challenges doing it within the US itself, which would be surprising. I mean, if you think about India, there are so many languages in India. Of course, it's going to be different, right? But in the US, everyone speaks English, but accents make a big difference. A Southern accent versus a Boston accent versus a Northeast, as in a New York accent, right, is already a challenge, and that's something that we've seen, right? Again, these these customizations already make a bigger impact than generic ASRs, right? If you use a generic ASR, for example, right, is already going to have a worse performance because of this issue, and that can slightly be reduced by adding these additional you don't always have to do AM tuning. These other things that we talked about in the flowchart already make a difference. Sometimes give you the small bump that is enough to make it usable for the downstream tasks. But we've seen in few cases it was really bad even after that, right? Which is a learning thing, in which case all that can help is better training for them, right? We need more data that actually works for those guys.
Yeah, thank you. Are there any more questions, audience? Please feel free to ask what you might not have asked earlier. Okay, so maybe one quick question is that all of this has to work on hardware and it's hardware optimized, right? So the current I assume quantization and the current set of tools that are there. And then I've seen Google also with several papers on optimizing for hardware speech models. Are they enough to make it work in real time in practice without losing accuracy?
Um, Again, that's where the going by specific domain solutions makes a difference, right? Because you will lose when you have to do these kind of things, right? When you have to go smaller footprint, latency, and all those things is going to come at the trade-off of dropping accuracy a little bit. That's when these additional customizations or domain contextualizations, right, bring you the bump enough to make it practically usable again. Um, if it's already giving you like 1% error, right? Making it 0.5 is not going to make a difference. But because it actually is not 1%, it's actually 10% or 15%, these bumps make a big difference. And that happens because of these additional challenges, right? It has to be the quantization, the on-device stuff, latency, you need to be, those practical challenges do not have resulting in 99.8% accuracy that we see in state-of-the-art results, right? That doesn't happen in practice. It's actually much lower. And which is why these bumps is what brings you to closer towards that real usable performance, right? Which is practically usable, acceptable performance.
Awesome. Yeah, yeah. There's one quick question. The session is ending. How does the business model compete with other commercial voice assistants?
Um, that's a question that's outside my domain. But see, the point is, one clear thing is that voice assistants are there. It's not we haven't recreated the world, right? Voice assistants are there, but we are solving for our problem, right? And that's the basic thing, right? And these problems are well studied. It's not like they haven't existed before and everything, right? But what we've observed is that AI solutioning is different than AI research, right? And that's basically the point over here. There are voice assistants. They do their things, and but we do our things in a way. Um,
That was very subtle. Yeah. Well, thank you so much for taking us through the whole map and yes, RNLU and the it's really important. I think for more and more for students to learn and appreciate the gap between research development and there's
Absolutely.
a lot
That's
of
something I've learned in person firsthand, right? But that's something that's extremely different and valuable.
and I wish more people knew it from early on, and that will help them decide better versus getting cast into one mode.
Absolutely.
Yeah.
Thank
Yeah.
you very much, guys.
Thank you so much, Aditya. We are very privileged to learn from you. And if you
It
guys
was
have any
wonderful having
questions,
this
you can
conversation.
ping him or you can ping me, and I can pass
Yes.
your questions back
We'll be
to.
glad to have any conversations on this. Thank you very much, guys. Thank you
Yeah,
very much, Nishant. Thank you
thank
for
you,
hosting me.
Aditya. Yeah,
Bye bye.
closing session is backstage.